Hello again. Was that too loud? Okay, we're back in business. This is the third time I'm going to record the determinant. Man, determinant. 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 What is a determinant? Determinant is a way calculate to calculate the cross product between two vectors. So let's get two vectors in our, I don't know, scratch pad, whatever you call it, vector A and vector A and vector B with this color, cross vector B, this color, they are beautiful colors, is equal to, this is one of the notations, is equal to the determinant of vector A and vector B. So how do you calculate the determinant? How do you do it? How do you do it? First of all, let's visualize how you can take the cross product. Let's get vector A. Let's draw vector A. This is vector A. Ooh, that's a straight line. And vector B. That's not a straight line. And vector B. That's vector A. That's vector B. And the angle between them is named theta. Of course, this is all standard. So how do you take the determinant of two vectors? So let's assume that vectors A and B have the same have the same have the same dimensions, meaning the number of components they have are equal. So get a let's assume we're in a two-dimensional world. So actually I should switch notations. So say we have x1 I hat, that's one big hat, plus y1 j hat, and vector b vector b is x2 I hat plus y2 j hat. So how do we take the determinant of these two vectors? Again, I'm repeating myself over and over again. Alright, let's choose a color orange. Actually, let's get more room. Here, be nice. This is the determinant. Let's make it clear. det vector A comma vector B is equal to two bars, one at each end, and I'm going to draw a imaginary lines, so that you can clearly see four grids or four cells, you can say. And what do you put inside these cells? In the first row of cells, you're going to put in the components of the first vector, and in the second row you're going to put in the components of the second vector. So first to first, second to second. Hopefully we're clear on that. So vector A is color green, so x1 y1, and you can of course you can draw or write I hat j hat, but you'll soon see why. Actually, should maybe draw it just so you can get an intuitive view. Alright, and I hat, j hat, and vector b has this color, x2 I hat, x, no, not x, y2 j hat. So how do we get these components? So you want to multiply the, so what you want to do is multiply these, let's draw it in a neutral color, multiply these two, and subtract it by this color, by this, actually no, that's not neutral, by this. So that would look like x1 I'm having a mental breakdown. Oh no. Wait. I I was thinking about how I could explain having I hat j hat in these cells. But apparently I can't think of an explanation to do that. So let's leave it out for now. It's just x1, y1, x2 and y2. So it will look something like this. So x1 y2 minus y1 and x2. This is how the determinant should look like. And notice that there are no I hat or j hat components, even though I drew in the I hat and j hat components here. Sorry for the confusion, but yeah, I'm quite dumb at times, and just bear with me. Just bear with me. Alright. So this is kind of like a scalar value. This is a scalar value. There's no direction, which is weird. This determinant is supposed to be the cross product between two vectors, not the magnitude of the cross products or just the direction. It's the entire vector. So what's the big idea? Alright, let me think for a while. Nah, I can't think of it. Alright, let's hmm let's do a 3 by 3 determinant. Just so you know, this is a 2 by 2 determinant, since there are two there are two two and two of these here, 2 columns, 2 rows, that's what I meant. So now this is a 2 by 2. Now we get into the 3 by 3 determinant world. 3 by 3 determinant, which means we would require, what's the determinant of vector A and vector B, where vector A, actually let's use different names, vector X and vector Y, where vector X has 3 components, is a 3-dimensional vector, and vector Y has 3 components as well. It's a 3-dimensional vector, of course, otherwise you can't really get the dot product. Actually, you could just insert a 0 in the empty component, but never mind that. So X has components of X, color Y, color yellow, color Y. X has components of, let's use this notation. X has components of X1, Y1, Z1, not a parenthesis, and vector Y has components of X2, Y2, and Z2. So how do you take the determinant the 3 by 3 determinant of two vectors? So let's get some room here. Alright, this is, oh no. Alright, we're back. Alright, we're back. Where we last left off was a 3 by 3 determinant, and we would want to find the determinant of the vectors x and vectors y. So let's get a determinant, and I'm again, like the 2 by 2 determinant, I'm going to draw imaginary lines with this color, 9 grids, of course. And what should I put inside these grids or cells? So the second row, you're going to put in the vectors of the components of vector x. In the third row, you're going to put in the components of the dy vector, and the first row, this is important, guys, you put in the I hat, the j hat, j hat, and k hat, respectively. I like to call these the unit vectors of our three-dimensional world, because in the x direction, y direction, and z direction, if you move, let's get another color. If you move one unit to the one unit in the positive direction, in the x direction, in the x axis only, that's what we call the I hat unit vector. Same goes with j hat. You move one unit in the y axis only, that's j hat. And k hat is you move one unit in the z axis, that's k hat. So we input everything into this determinant. It's going to be I hat, j hat, k hat, x1, y1, z1, and x2, y2, z2. That is how a determinant looks like, except for the imaginary lines, but you can ignore that. So what is this equivalent to? What does it equal to? How do you solve it? Alright, let's get this beautiful color. That's equal sign. Flip vertically. Is that correct? Oh well. So I'm going to write out the equation first. And then give you the pattern. Hopefully that that that's okay with you. So y1, let's try to picture it in my mind so we can have beautiful writings. Y1 Z2, never mind, actually that's not the correct color. Y1 Z2 minus y1 z2 z1 times y2. Oops, that's not z1. z1 y2, that's correct, parenthesis, times the i hat component minus j hat times oops, actually I'm just going to put the j hat in. Nah, it's alright. Alright, j hat times x1. Alright, x1 z2 minus x2 z1. That's 2 right over there. That's 2. Close parenthesis. And plus, oh, look at that. Plus, I'm going to move downstairs. Plus, oh no. Plus k hat times the difference between x1 and y, between the product of x1 y2, and I'm just not going to switch colors anymore, got too tired of that, and x2 y1, x2 and y1, yet I still switched colors, y1, and that is the equation. That is the equation to a 3 by 3 determinant, and the cross product of or the cross product between two vectors of three dimensions or three components. So notice this is a vector. This is a majestic vector. This is a vector, and I'm going to show you the pattern right now. I'm just going to pick the colors. So first step, or first term, I guess you can say, is that you have to multiply I hat with the difference between the product of y1 and z2 and the product of z1 and y2. That's the first step. The second step, I'm going to use color blue, is you multiply j hat with x1, with the difference between x1, between the multiply j hat with the difference between the product of x1 z2 and z1 x2, and where's k hat what color purple, nah, pink. K hat is you multiply x1 and y2 and subtract it by y1 and x2. Is that correct? y1 x2, hopefully I am correct. Let me check. Yes, I am correct. So that's a 3 by 3 determinant, but I think I have to explain to why this is a vector and the 2 by 2 determinant a while ago isn't a vector. So the main difference that I have noticed is that when you take when you take the 2 by 2 determinant, when you take the 2 by 2 determinant, there is no room, essentially there is no room for I hat or j hat, but that but I think we should have a visual understanding for it. So let me draw a y-axis and x-axis, y-axis, x-axis. Oh, I didn't. Oh well. Y-axis, x-axis. And I'm going to draw two vectors. This vector, this vector, and this vector. This vector. When you take the cross product between two vectors, of course, the resulting cross product's direction of the vector is going to be perpendicular to both to both to both the to both the first vector and the second vector. So the only way possible of that happening is introducing third a third a third component, in which case in our real world it's kind of like a z-axis. The vector direction of the cross product, in this case it's either going to be pointing towards you or pointing towards the screen. But in a 2 by 2 in a 2 by 2 determinant, I think this is how I like to think about it. There is a constraint that you should only use the n by n, where n is the dimensions of the determinant, the nth dimension to graph. So if that doesn't make sense, we can't if that doesn't make sense, I'll explain it much simpler. We can't, again I repeat, we can't have a vector that is perpendicular to both these two vectors but is not a three-dimensional vector. Does that make sense? I don't know. Let's draw a three-dimensional space instead of a two-dimensional plane, and show that you can indeed get get uh get the what do you call that get the perpendic get the perpendicular line to a plane. So let's draw the same no, not the same vectors. This vector, an arbitrary vector, and vector yellow. So first of all, I like to draw a plane whenever I want to draw a perpendicular line in 3 dimensions. So this is how I like to draw a plane. So this plane is going to look an example of a plane could look something like this. And the perpendicular line we could easily draw. Forgot to label the axes. This is the x-axis, the y-axis, and the z-axis. And the perpendicular line, color green, it looks like this. And that is the intuition to why it's quite different whenever you take different dimensions of determinants. Hopefully you find that useful.